Is it working? Yes. Thank you very much, Julie, for the introduction. So the title, you've mentioned it already. Some of you may have actually been here last year when we did a similar workshop on dynamic light scattering. One of the feedback things that we got was we shouldn't work through dinner, which we did last year because we wanted to cover so much material, we kind of raced through all these slides. So what we're going to do this year is we're trying to compact this around dinner, but at least leave half an hour for dinner so that we can actually maybe discuss loosely a little bit what maybe your problems are. But the dinner itself is not going to have slides flashing around here. So we have quite a few slides in this notebook. I haven't looked into it, but it should have most of these slides. And we're not going to be able to cover all of them, but it's meant to be a very nice point of reference for you. If you do have any particular slide that you see on there that you want to get back to at the end of a session or in the middle at the break or at the end afterwards, just grab us. So it's a big list here. Initially, I thought we'd want to separate it into three kind of equal parts, but we've changed the splitting a little bit, so these lines don't necessarily mean who's talking. But essentially, I'll be talking first, then Mark will be next, and Kevin Madison will be the last speaker, and you will all kind of do this jointly together. The initial part here is about light-matter interactions, dynamic light scattering, general scattering intensity, what is hydrodynamic size, what's polydispersity, then going into the different algorithms, what's intensity weighing, distribution, transforms, and accuracy, precision, all these things. You see them there, and we'll have a little quiz and discussion at the end. I think those of you that remember that from last year thought that was very interactive. So I'll just get started with the meat of the presentation now. And I'm planning to be finished at 5:30 at latest. So if I'm running over, give me a sign. Light, matter, and interactions, and what does the scattering intensity do? When you have light interacting with some material, be it a protein, be it a particle, be it even just a liquid, there are different ways of how light can interact with that material. It can either go through, be transmitted, or it can reflect from the material. It can be absorbed. It can fluoresce. So there's lots of different ways. And one thing that we are really concerned about is scattering, meaning the light kind of bounces off the material, or it gets very briefly absorbed and re-emitted. So you can think of it as a little dipole that's induced in your little molecule or particle in the middle, and that then re-radiates light into all directions. And here we have a little Hertz dipole scattering profile. And you can look at the intensity, the amount of light that's scattered, as a function of angle. And so here we have at 90 degrees a detector that looks at the vertically polarized scattering light. And in this particular case, we're talking about a Rayleigh scattering profile. This is the reason why the sky is blue. It's very isotropic scattering. It's from small particles, from small air molecules. They relatively overwhelm the scattering from any bigger particles, and there aren't really any bigger particles up in the sky, very high. So the way you can think about it in an instrument when you want to measure this in a more regular setup, we have this terminology that we call something a scattering volume. Here we have a laser that shines into your sample, and there are lots of little molecules in here, and they re-radiate the light. But the detector is actually only going to pick up light from some direction. So the detector is not going to pick up all the light in all directions. It just looks at one particular scattering angle or a particular scattering volume. So really